Good day, everyone. Welcome to Jamovi for Educational Research Tutorial Series, Episode 8, ANOVA or One-Way Analysis of Variance. What is ANOVA? If t-tests compare the means of two groups or conditions, one-way analysis of variance or ANOVA compares the means of three or more groups or conditions. ANOVA has been described as an omnibus test which results in an F statistic that compares whether the dataset's overall explained variance is significantly greater than the unexplained variance. One-way analysis of variance makes the same assumptions as most other parametric tests. Here are as follows. The independent variable must be categorical, and the dependent variable must be continuous. The groups should be independent of each other. The dependent variable should be approximately normally distributed. There should be no significant outliers. There should be homogeneity of variance between the groups, otherwise, the p-value for the F statistic may not be reliable. The first two assumptions are usually controlled through the use of appropriate research method design. If the last three assumptions are violated, then the non-parametric equivalent Kruskal-Wallis should be considered instead. For the one-way analysis of variance or ANOVA, we have this sample situation. A supervisor wants to determine if school class size has an effect on the performance rating of teachers. He compared the performance rating of teachers from small, medium, and large schools. Here are the tasks that we will go through in this tutorial. Perform the test and check the assumptions. Interpret the results. Report the analysis. Once your dataset has been successfully imported in the Jamovi software, you're now ready to perform the test. So make sure to keep your focus on the process. Let us now begin. In Jamovi, there are two options for running one-way analysis of variance. You can either click one-way ANOVA or ANOVA, but both have downside. If you click the first one, one-way ANOVA, there is no option for effect size. If you click ANOVA, there is no option for Welch ANOVA and descriptives. But let's see what will happen if we click the first one-way ANOVA. As you can see, there is no option for effect size. If you want to get the effect size, you have to run it using the other option. Now, let's take a closer look at this. Take note that if homogeneity of variance is violated or getting a significant result of Levene's test, click Don't Assume Equal or Welch. If the result of Levene's test is not significant, meaning there's no violation in the homogeneity of variance, click Assume Equal or Fisher's. Fisher's is the classic ANOVA. Let us now continue. Now, let's try to click the other option, ANOVA. As you can see in this one, yes, there is option for effect size, but there is no option for Welch ANOVA in case that the homogeneity of variance is violated. Whether you click one-way ANOVA or ANOVA, the result is just the same. If I were to choose, I'd click the ANOVA option, then if it happens to have a violation in the homogeneity of variance, then I'll do it again with the other option. Now let's have some additional information. Here are the differences among the effect size used in ANOVA and post-hoc analysis. Just take a closer look. This information is taken from JASP Guide for Students. When it comes to interpretation of results, these are the parts that you have to pay attention to. For the results of the mean statistics or ANOVA, always look at the p-value, which should be less than 0.05 for it to be significant. Effect size is also a must check since it helps us understand the magnitude of differences found, whereas statistical significance examines whether the findings are likely to be due to chance. In one-way analysis of variance, the most commonly used is partial eta squared. And here is the guide for interpreting effect size for ANOVA. We will look at the partial eta. If you get less than 0.01, the effect size is trivial. If you get 0.01, the effect size is small. If you get 0.06, the effect size is medium. And if you get 0.14, the effect size is large. For the homogeneity of variance, you have to meet this assumption by obtaining a p-value of greater than 0.05. If you get less than 0.05, it means that the assumption for the homogeneity of variance is violated. The same with the normality test. To be able to meet this assumption, the p-value obtained must also be greater than 0.05. If it violates the assumption for homogeneity of variance, although it doesn't violate the assumption for normality test, use Welch ANOVA. If it happens to violate the assumption for normality test, even if it doesn't violate the assumption for homogeneity of variance, use its non-parametric counterpart or alternative, which is the Kruskal-Wallis. Post-hoc test is used to compare the groups pairwise, using statistical correction to avoid type 1 error, where the null hypothesis could be rejected when it is in fact true due to stricter acceptance criteria. Take note that it should only be conducted when the result of ANOVA is significant, otherwise it is meaningless. This is how we interpret the results. You compare large versus medium, then examine the p-value if it is significant with less than 0.05. Next that you'll compare is large versus small. Again, look at the p-value. Same goes with medium versus small. For the descriptive statistics, report values for mean and standard deviation or ST. Report the analysis. This analysis report follows the APA format, provided with the tables of results for inferential statistics, descriptive statistics, the assumptions for normality tests and homogeneity of variance, and the post-hoc analysis. This is how you should report the analysis in order. Take note of the terms in blue font and the format of reporting values in red font. The study aims to determine if school size has an effect on teachers' performance. The teacher's performance was measured using the Individual Performance Commitment and Review Form, or the IPCRF. Prior to conducting the analysis, tests of normality and homogeneity of variance were examined using Shapiro-Wilk statistics and Levene's test, respectively. The result of Shapiro-Wilk's test showed that the assumption of normality was not violated, represented by the given values. And the result for Levene's test indicated that the assumption of homogeneity of variance was also not violated, represented by the given values. The result of between subject one-way ANOVA reveals that teachers' performance significantly differs among the teachers who are teaching in different school sizes, represented by the given values. There is a medium effect size in this analysis with a given value of 0.076. Variation in school size accounts for 7.6% of variation in that teacher's performance. Post-hoc analysis using Tukey's HSD showed that the significant difference in teachers' performance is only found between the large schools, represented by the given values for mean and SD, and small schools with the given values. The findings suggest that school size has an effect on teachers' performance. Teachers in small schools perform better than teachers in large schools. And that ends this session. Thank you for watching Jamovi for Educational Research tutorial series. Stay tuned for the next episode. See you next time.